Okay, so again, common sense, and it sounds so. Common sense sounds like it's supposed to be so simple, but it's not really, right? It's something, it takes practice. But here's a question that common sense makes it enormously easier to answer. Okay, so I don't know, anybody have friends like this? It's really annoying when you do, right? Because you got 10 people, there's a married couple, but the married couple, of course, they won't do anything unless they're together, right? They won't split themselves apart, they have to be together. And so 4 students can attend this conference, but the married couple's only going to go if they can be together. Aww, right? Isn't that sweet? But how can we count the number of possible combinations for 4 students if we've got this weird situation here of the married couple may or may not go?
Don't make friends with married couples.
Don't make friends with married couples? I like that. Okay.
But then there's only 2 and 1 solution. There's only 3 solutions in a few cases.
Yes. I'm not sure I understand the explanation there. Treat them as one. So what do you want to make this 9 college students and they're this is Bajani again? This is J-Lo. This is what it's become, right? Or?
And then you can take out the possibility of like either one of those 2 being
I'll tell you, it's not easier to lock them together and make them benefer, right? It's not better. In this case, it's not going to be easier. What do you think? How could we do this? Give me a scenario. What's going to happen when they go? Think about it. What's going to happen?
That means only 2 students going to
2 students and the married couple? Maybe. What else could happen? 4 students and no married couple.
So 10 or 9.
So wouldn't it be easier if we thought about this problem in 2 possibilities? Number 1, it's with the married couple. We say if you're in scenario number 1, it must be with the married couple going. Otherwise, you're in scenario number 2 when there is no married couple. Because now I don't have to decide whether or not the married couple goes. In one scenario, that's the married couple must be there. In the other scenario, there will be no married couple. There's no overlap here, right? Because if the married couple isn't a part of section number 2, then whatever group I've chosen, it can't be the same group as the other one, right? Because it doesn't include the married couple. So how can we count it with the married couple? What could I put in here?
8C2.
Right, there's 8 people who are not married, pick 2 of them. And again, if just in case you like to count them, there's 1 married couple, pick 1. You don't have to do that part of it. I mean, it's not necessary. 1 choose 1 is going to be 1. But, you know, sometimes people are, well, you forgot to count them. How do they count? Well, 1 choose 1. Okay, what about the next scenario? There's no married couple going. Now how do we pick these? Yeah, 8 people who are not married, pick 4. Okay, and then you could say there's 1 married couple, choose none. Right? It doesn't have to go there if you use a bit of common sense, but these scenarios, again, it is either the married couple goes or the married couple does not go. So it's going to be added together. All the scenarios from when the married couple is in the group that's going and the scenarios when the married couple is not going. Okay? So if I added those up, that would tell me how many possible 4 groupings I could make to go to this conference with this really annoying married couple. Right? And then it's not going to be fun when you get there because you're going to be like, hey, there's a party down in the quad, we're all going, and then they'd be like, no, I think we're going to stay here and watch a movie or something else, and it'd be so boring to travel with. So, not that all married people are boring, but...
Just getting that on record?
Yeah, just put it on record there since I am. Okay.
You're very fun, Mr. Joyce.
A standard deck of 52 playing cards. Here's the weird thing is sometimes the provincial exam, they assume that you know this kind of stuff. So they won't put this nice chart on it. Sometimes they do. If it, for some reason, if the stress has gotten to you and you're like, oh my god, how many kings are in a deck of cards? Please ask, because that's not a math question. I don't see any problem with the person giving you that information. It's not going to help you with Math 12. But if they're nice enough to give you the chart, then you don't need it. So let's see how we're doing. We're going to see, we should be able to do this fairly quickly if you're getting the hang. How many different 5-card hands can be formed from a deck of cards? That is correct. So roughly, can somebody just quickly tell me, about how many is that? Other than a lot. Maybe like two digits, like, what is it?
2,598,960.
So about 2.5 million, something like that? Okay.
2.6.
So how many different red card hands can be formed?
13 C5. 13 P5.
Well, does everybody know what cards are red on the deck of cards?
26 C5.
Okay, yeah, 26C5. So half of the cards were red, so it's 26C5. That's what I'm going to be pulling as my choices. Only choose from the 26 that are red and choose 5 of them. Okay, how many different 5-card hands can be formed that consist of all hearts?
13 C5.
Great, there's 13 hearts, so we want to choose 5. What's that called in poker?
Flush.
Yeah, so right now, how many suits are there? 4. So this times 4 gives me the amount of possible ways to be dealt a flush, and I know how many possible hands there are. You can calculate a probability of getting a flush.
And then go win some money.
Well, it's not very high, so I wouldn't go betting on getting a flush. It's pretty hard to do. Okay, how many different 5-card hands can be formed if they have to be all face cards?
12 C5.
Yeah, there's 12 face cards, so 12 cards, only choose 5 of them. How many different 5-card hands can be formed that consist of at least 1 heart? Okay, remember, common sense is when you get stumped,
52 C4.
Oh, never mind.
tell me a scenario. What's one scenario?
52 C.
52 C4.
Those are answers. Tell me a scenario.
When you have 4 diamonds and 1 heart.
Okay, 4 non-hearts, 1 heart. What else could you have?
All non-hearts.
3 non-hearts, 2 hearts. Okay, so if we added them all up, there are 13 hearts, and I'm going to pick 1, 39 which are not, to choose the other 4 cards. Or 13 hearts, choose 2, 39, choose 3, or 13, choose
I'm gonna
3.
wait for the fast version.
What makes you so sure there is a fast version?
Because there is.
Well, let's finish this here just to show you what we'd be going through here.
My logical reason is because mathematicians are lazy and want fast version.
Well, they certainly are.
And they all heard that just now.
It's okay.
Okay. There. Simple, right?
Yeah, very.
But it takes a lot of stuff to write out. This is the cases that you go over in your head. 1 heart, 4 non. 2 hearts, 3 non. 3 hearts, 2 non. 4, 5, all the way up, okay? So how could I do this quicker?
Look off the person beside you.
Look off at the person beside you.
Hopefully they're smart.
How could I count
No,
it?
come on, sit here.
Well, okay, so you say indirect, and that's correct. So how would I do this indirectly, though? What am I trying to avoid? What do I not want to have happen?
No hearts.
No hearts. Okay, so we want to take away the heartless hand. Okay, so there are 52. Whoops, let's try that again. There are 52. Choose 5 hands. We don't want, what we want to remove from that is all cases when we might have no heart. So that means I have a hand which is 39, choose 5, because there's 39 non-hearts, and all 5 of them I use. So this is removing the case when there are no hearts in the hand. Okay. How many different 5-card hands can be formed that consist of exactly 3 hearts?
52 choose 2.
We don't want to pick from all 52 just yet.
39.
Oh wait, hang on, yeah.
39.
Okay, so we can pick 39. How many cards am I going to pick from those 39?
2.
2, and then that means I need 3 from the hearts. Okay, so exactly 3 that are hearts, 39 that are not. Okay.